IED, this is project 1.3.7, Design a Protective Case. We're going to focus this time on the beginning of the project, which is defining the problem. We're going to talk a little bit about what I expect in my class and maybe what, if you're not in my class, what you would be expecting in other classes as well too. Last time we talked about the design brief and the client and basically what was actually going down with the problem itself. So when we define the problem, what we're going to do is the thing we need to add to this design brief is a design statement that describes exactly what you will do in phase one of your project. Okay, so we're only actually going to be doing phase one in this project, so you don't have to deliver like a finalized product or anything. Maximum case scenario, you'll be making a 3D printed prototype, and because of class restrictions, there's probably a good chance you're only going to have one go at that prototype. Because I don't think you're going to have the class time to be able to just say like, oh, I want to make like 5 different prototypes, because usually 3D printers are a valuable resource, especially when there's a class size of 20 to 30. So you're probably only going to get one go on that, and that's just going to have to be the way that it is. So that's going to be your proof of concept. It may not be perfect. There's actually a 95% chance that it's not going to be exactly what you would finish off in production. And I'm being very conservative with that percentage. So there's a vast, every time you make something, there's going to be some room for improvement. So in that design brief, you need to add a design statement, and we're going to add some measurable criteria. And a measurable criteria essentially is something that you can get a number to. Like, you can't make a measurable criteria like, I'm going to make an earbud case that makes people happy. Well, what do you mean by happy? Happy is not a measurable criteria because you can't put a number to happy. Like, I would just ask you, like, are you happy? And you'd be like, 7. That's a number. That's not an actual rating of your happiness. So it has to be a measurable criteria. So easy things to go for measurable criteria is to talk about, limitations on the mass of the object or how much volume it takes up, how secure the earbuds are, or whatever we're actually using. I think whenever I design this project, I think I'm going to make it to hold flash drives, or I also have some like little resistors. I might actually make a resistor holder case too. I think that would be kind of neat. But whatever it is, you need to come up with some kind of criteria for it. How many flash drives could it hold? If it's earbuds, does it keep the earbuds in properly? Things like that. And a couple of other criteria from the design is like the material cost. If you're making it out of PLA versus making it out of PETG, those are two different types of materials. They have two different costs that go along with them. Obviously, if you're making it out of something like a wood or a metal, that would be even more expensive. The development cost, how long is it going to take you to make it? How long is it going to take you to refine the process? All of these things in the real life scenario cost you money. So you can actually add that in as your criteria as well too. Your reusability, you could talk about that. How long does this thing last? Can you reuse it multiple times, or does it serve multiple purposes? You can see tools or containers that actually serve multiple purposes. Can it be reused? Can it be recycled? Things like that. The cleanliness of it, does it get dirt in specific areas? I mean, you're going to be putting it in your pocket, so there's lint all over those places and stuff like that. You don't want like lint piling up inside the corners. How do you make sure that it stays clean? And you're also dealing with earbuds, so you're basically sticking those in your ears. So it's things to think about. Testability. How are you going to be able to test out your product? The lifespan. Every product has a lifespan. Everything will eventually go to the dumpster pile. But that's just how it is. Some things have a really long lifespan. Some things are meant to be easily consumed and have a short lifespan. Okay. Development time. It says development time. Sorry, that's development time. How long would it actually take to do this thing? The size of the object, company standard safety. So make sure, if you're talking about if you're going to make 10,000 of these, how can you make 10,000 of these safely? You're not going to be like just throwing this stuff around everywhere. And more specifically, it's not necessarily because a lot of people kind of start laughing at that, and it's not the case itself that's the dangerous part. It's the machinery that's making the cases 10,000 at a time. That's usually the safety issues that happen, and the function of the object. So if you talk about all of these inside that design brief, whenever it says adding material, adding a measurable criteria, then you're doing fantastic. You've got everything that you need for defining the problem, and in my book, I would say that that is 100% good to go. That's defining the problem, and that's what I'm going to be expecting from my students. So y'all have a great day, and I'll talk to y'all later.